So, are you ready? How are you feeling right now? It's like last talk, I know, you must be tired. I know I'm tired. We all want to get to the party. So I hope I'm gonna make this talk as fun and as interesting as possible for you, right? Because we all wanna go to the party right now. So, who am I? Who is this random girl in front of you? So my name is Claudia Hernandez. You can find me on Twitter as Costa4. If you have any comments, complaints, or whatever, if you just want to talk, you can find me there. I tweet a lot. If you're more into emails, you can find me at claudia.hernandez@dailymotion.com. And if you guessed by now, I work in this company called Dailymotion. So if you have never heard about Dailymotion, Dailymotion is a video sharing platform based in Paris. A lot of people are very, very surprised that this is a French company, but it is. So I'm very excited to be talking in Russia. It's my first time here, so I'm really, really happy to share with you some of the weirdest things in JavaScript that I have encountered in my career as a JavaScript developer. So Dailymotion, I work for that company. For the past few months that I've been working at Dailymotion, I've been working in a very, very exciting project. And this is how Dailymotion looks like right now. And I mean, I'm not a designer, but to be honest, this design is not very, very, very awesome or impressive, right? Basically what we did, this is the watching page. We have like the videos, we have related videos, and it's okay. But for the past 8 months, I actually work in this new redesign and rebuild of the whole platform. So the old Dailymotion, the one that you're seeing just right now, it's built with in the back end with Symfony, and on the front end we were using this templating system called Twig. So if you know about this, it's like a little bit old. It's time to change, and what we're working on right now is with React, Redux, Apollo, and GraphQL. So it's very nice because I've been having the opportunity and liberty to actually rebuild everything from scratch with a whole new, fresh design using these new technologies, and I promise you, I have learned so much in the past months. So I'm very excited to talk about this and to show you a little bit of a sneak peek of the new Dailymotion, because it's gonna be coming out pretty soon, actually this month. So this is how the new Dailymotion looks like right now. We have like this kind of a home page, and we have a feed space, Explorer space. Everything is built with React and Redux. This is the new Watchix experience. We have some mini player, and it's nice. This is my work for the 8 months. I'm very proud of it, and it's coming soon. So just keep an eye on that. It's coming in this month. But of course, you didn't came here to talk about Dailymotion. Let's put that aside. Actually, for the rest of this talk, I'm going to be your own personal white rabbit, because I'm gonna be showing you some really weird things going on in JavaScript that I hope are gonna make your minds blow. So, I'm a very, very curious person. I mean, I'm not an expert, I'm just a developer, right? But most of the things that I'm gonna be showing you right now are things that I have encountered myself through my career as a JavaScript developer. And you know what? I just love knowing how things work. So most of these things, I didn't know what they were, and I just studied them. I just went to the internet, and I was like, what? It's going on. I just need to know. So this is what I'm gonna be showing you next. So the beauty of JavaScript. We all love JavaScript because it's very quirky. Because, you know, math min is, of course, not less than math max. Is like, what? And the thing is actually that this clicker, math max is equal to minus infinity, and math min is equal to infinity for some weird reason. Like, we will normally would think that math max is bigger than math min, but not in JavaScript. And of course, you were here in the first talk of Douglas Crockford, and he has already explained this example. So we all know that this is false by now, because he did a great job explaining the keynote talk that this is actually 0.300004, right? This is just part of the quirkiness of JavaScript, and it has to do with the inconsistencies with floating point numbers. But I mean, I'm not going to explain it. He already did a great job explaining that. So what about this? Like, raise your hand. The people who think that the console log of A is this one. Like, do you think this is the correct console log? Raise your hand. Nobody? Okay. What about this one? No? Okay, so actually the correct answer is 10. And why is that? This is octal numbers. Actually, when there is a leading 0 and the following number is less than 8, JavaScript is processing the whole number as an octal number. So, I mean, these are things that we will normally don't know, just somehow happens. And it's weird when you don't know that JavaScript treats numbers in a different way. So what about two equal-looking arrays? Like, we would normally think that this is the same thing, but of course it's not the same thing, because we have to know the difference between primitive types and reference types in JavaScript. So what have I just shown you? It's like, I'm not going to go into details into the previous examples. They're just like quirky things that I have encountered. As I told you before, Douglas Crockford already did a very good job explaining the inconsistencies with floating point numbers in different languages. But I mean, what I really want to point out is that JavaScript is very easy to learn. But the thing is that it's also very easy to fuck up. So what I'm going to be showing you next is just these really quirky things that I hope are going to help you out in your following years as a developer to just avoid some headaches. So this is the first part of our journey through Wonderland. And our first stop is NaN. So I give it away. NaN actually stands for not a number, but as you just noticed, type of NaN is equal to number. So, you know, in very simplistic terms, NaN is just the return value of a mathematical operation that failed. So if we try to do operations on operations without both operands being numbers, we will get NaN. And if we try to do operations on numbers that are not defined, just like the example we saw today morning, we will also get NaN. If we try to get the square root of a negative number, we will also get NaN. So in a very simplistic way, NaN is just trying to tell us, like, hey, I tried to perform this mathematical operation, but I failed. So here's this fail number instead. So maybe the problem with NaN is that the label NaN is a little bit misleading. Maybe it will be easier to understand it if we thought of it as fail number or bad number or maybe invalid number more than not a number. Because the bottom line is that NaN is just the return value of a mathematical operation that failed and that could not return a valid number. So mathematical operations in JavaScript cannot lead to an error or crash. They just give us NaN. It's like easy peasy. So what if we actually wanted to know if a value is equal to NaN or not? If this was your first guess, let me tell you something. NaN is actually not equal to, greater than, or less than anything, including itself. And why is that, you might be wondering? So NaN is not just a JavaScript thing. NaN is also actually defined by this IEEE 754 floating point standard. And to keep things short, basically this standard says that there are 16,770,214 different floating point numbers as NaN. And I mean, this actually means that there are so many different ways to represent a NaN that it's highly unlikely that one NaN is equal to another NaN. So yes, indeed, NaN is not equal to NaN. And at this point, I guess we can all say that NaN actually stands for not a number. Now, the only way to actually know if a value is NaN or not is using JavaScript built-in function is NaN. So now let's talk about the tilde operator. How many of you knew that this is what's called a tilde operator? Ah, good, you're my people. So actually the tilde operator is a bitwise operator. And what's that? So the bitwise operator, sorry for that, it's just an operator that will take an integer, it will transform it into a sequence of 32 bits, then it will do some kind of operation on it, and it will return back the result as an integer, and that's very important. Perhaps you are more familiar with the bitwise AND and the bitwise OR, but huge warning, this is not the same thing as the logical AND or the logical OR. But actually, there are 7 different kinds of bitwise operators in JavaScript. So, but we're going to be talking about the Bitwise Knot right now. So actually what the Bitwise Knot is doing is it's just inverting all of the bits in a sequence of bits. And I mean, we hardly have to do such detailed bit-to-bit operations in our daily applications. So let me put this in a different way. So basically, the bitwise operator is just doing this small algorithm. It's just adding 1, and it's changing the sign. So basically, we can give it a -2, and it will return a 1. We can give it a -1, it can return a 0. We give it a 0, it will return a -1, etc., etc., etc. Now, the million-dollar question here is, what actual real-life application can we give to this funky-looking operator? And here's one case. So we could actually use it to truncate numbers. And this is actually faster than using math_trunc or math_floor. If we use a double bitwise operator, it's very good. So we could actually also use other bitwise operators to achieve the same thing. And as I told you, this is faster than using math_floor. But let's keep talking about the bitwise knot, right? What other use can we actually give it? So imagine that we have an array with a list of people that are going to be invited to the tea party or to the after party right now. And what if we want to know if an element is in an array or not? So there is this method on arrays that it's called index_of, and it was also mentioned in the morning, so that's really good. And basically this index_of method will return a -1 if an element is not found, and if the element was found, it will just return the position of that element in the array. So a lot of developers have used this technique or this method to actually know if an element is in an array or not. So what most developers do is they just compare the result of index_of, and they will check if the result is bigger than 0, less than 0, equal to -1, different than -1, and it works. But actually, you could actually summarize all of this or simplify this by just using the tilde operator. And the way it's working right now, it's if the element was not found on the array, it will return, index_of will return a -1, and when you pass it to the tilde operator, it will transform it into a falsy 0. So it will mean that the element was not found. And in any other case, the tilde operator will produce a truthy value. So before people start getting very angry at me and like hitting tomatoes and stuff, it's like, I know this is not very human readable, and it's like, it's not code friendly, and it's not friendly for your colleagues. But the good thing is that actually ES7 is going to have a new function that is array includes. And it's very, very nice because it's actually just going to bring back a Boolean saying if the element was found or not. So either way, it's pretty, pretty cool. So let's talk about for loops right now. And I know for loops doesn't sound like very, very exciting or like there is something to talk about them. But actually, once I saw this really weird, funky looking for loop. So when I saw it the first time, I was like, what's going on? Like, how come it's working? So let me remind you something very basic about for loops that I'm pretty sure that you know. Just bear with me. For loops have 3 parts. They have an initialization part, they have a condition part, and they have an iteration part. So what I didn't know is that all of these parts are optional in JavaScript. What does this mean? This means that you can actually skip the first part, the condition, the initialization part, because you can actually declare the variables outside the for loop, and it's okay. You can skip the condition part, and if you do that, JavaScript will automatically consider this part as true, and it's up to you to break the loop wherever you want. Or you can also skip the third part, and in this case in particular, what's going on is that the condition part is acting at the same time as the iteration part, and once this I drops until 0, it's going to produce a falsy value, and it's going to get out of the loop. Or you can even just skip everything, as I show you in the first slide. And if you do that, if you remember from the previous slide, the condition part is going to be considered as true. And this is the same thing as a while true. And just basically, this really we're looking for is just an infinite or endless loop. Up to you to break it whenever you need to. And this is the last part of the first part. And let's talk about undefined now. So we all know that undefined is a variable that has been declared, but at the moment holds no value on it. So I think this piece of code is not shocking to anybody, right? actually, undefined is part of the global object. It's part of window. So what if we want it to be like very intelligent or maybe mischievous, and we want to redefine undefined? Do you think that's possible? So what do you think it's the outcome of this? And actually, the answer is that it depends on the browser that you're running it. So you can actually redefine undefined in older browsers. From Internet Explorer 8 and below, this can actually be defined. And the good news is that modern browsers have already fixed this bug. So here's the thing. I know that it's we hardly have to deal with this kind of things, but if you have to give support to older browsers, you have to defend yourself against the possibility of maybe someone redefining your undefined. Because the thing is that JavaScript rarely runs in isolation. It often runs with third-party libraries, with external codes, and you just have to be aware that this could happen. And that's not all. And as crazy as it sounds, undefined is actually not a reserved word in JavaScript, which means that you can actually use it as a variable name. And of course, I totally don't recommend that because it's just going to mess up a lot of your colleagues. What have we learned so far in these few minutes? So not a number is a number. The tilde operator is the Bitwise Knot operator. All parts in a for loop are optional, and undefined can be defined. Well, sometimes. So now let's talk about sorting arrays, because that's always such an exciting activity, right? Like, who doesn't love sorting? Can you tell me what's seriously wrong in this example? Like, is something funky looking over there? No? Because I don't know about you, because normally 25 and 33 comes after the number 4 and not before. So what's going on? Is like, it's JavaScript drunk, or in which world, you know? So what's actually happening is that JavaScript is doing this thing called lexicographical sorting. And what's that? So lexicographical sorting is just dictionary-like, telephone book-like kind of sorting. So just think of it as alphabetical sorting, not numerical at all. So what's actually going on is that JavaScript is transforming all of the elements in an array into strings, and then it's comparing those strings according to their Unicode code point value. And this Unicode code point value is just the ID of any Unicode character. So now let's see an example. We have a colors array, very simple. We have a red, we have a blue. We call the sort method, and blue comes before red, right? Because alphabetical order, it's normal. And in the second case, we have a numerical array with 80 and 9. And when we call the sort method, this will be the exact same thing as if we call that same array with those numbers as strings. So in this case, 80 is coming before 9 because 80 has a smaller Unicode code point value than 9. So in a more simple way, we can just say that 80 is lexicographically less than 9. If we actually want to know the code point value of any character, we can just use JavaScript built-in function code point add. Now that I have already explained that JavaScript is just transforming everything into strings, I hope that this code doesn't shock anybody, because basically what's going on is, in the first part, we have an emojis array, and actually emojis do have Unicode code point values, so for JavaScript it's just very easy to sort them as well in some way. So in the second example, we have an array with a number 390, an emoji, a string as well. For JavaScript it's all the same, because it's just transforming everything into strings and comparing according to their Unicode code point values. But let's go back to my first example. So it now starts to make a little bit more of sense, because 25 and 33 are indeed lexicographically less than 4. So JavaScript, it's correct. However, what are we missing? I guess when we're trying to sort a numerical array, the lexicographical sorting is not the first thing that pops into our head. So what are we missing? So actually, the sort method can take as a parameter a compare function, and I guess this is what you have been doing most of the time, right? So if we give a compare function given A and B, if A is smaller than B, we will return -1, and A will come before B. If A is greater than B, we'll return 1, and B will come before A, and in any other case, we will just return 0, and the elements will remain unchanged. Now, going to my previous example, if we actually provide a compare function, we can finally achieve a numerical sort, which is what most of you have been doing for years, I guess, I hope. So here is the thing. After all of this sorting nonsense or whatever, I actually asked myself, have you ever wondered which algorithm is used in JavaScript native sort method? Because this is just the kind of questions that I love asking myself when I have nothing else to do on a Saturday night. So the answer to this question is that the ECMAScript standard does not really impose as an algorithm to be used. So it's up to all of the browser vendors to just choose whatever algorithm they want to implement. So the good news here is that most of these JavaScript engines have their code open source. You can actually go to GitHub and see what they're using or what they are implementing. And that's exactly what I did. So I really love reading source code, and I really love reading the comments because I feel like they have a lot of really, really interesting information. So this is the source code of a SpiderMonkey, and what they're using is an implementation of the merge sort algorithm. And as I told you, I really love reading comments. And the first one says, this sort is a stable sequence of equal elements is preserved. Now, I'm going to be explaining the concept of stability in a few slides later, so just keep in mind that this algorithm is stable. And the second comment says, apply insertion sort to small chunks to reduce the number of merge passes needed. So basically what's saying here is that, in a general sense, SpiderMonkey is using the merge sort algorithm, and for smaller arrays, is using insertion sort, because insertion sort is a very good algorithm and very performant for small arrays. So this is Chrome's V8, and V8 is using an implementation of the quicksort algorithm. And just like SpiderMonkey, they're also using insertion sort for smaller arrays to improve performance. Now, Safari's Nitro is also using an implementation of merge sort, and Microsoft Chakra is using quicksort as well. And just to summarize a little bit what I have just shown you, if you're paying attention, basically the most popular JavaScript engines are just using a combination of insertion sort, merge sort, and quicksort. Now, why am I even boring you with this quicksort or whatever algorithm nonsense? Why would you even care about that? So this is not a computer science talk, but I really want to show you the implementations of these algorithms right now. And I won't go into details about the actual implementations, because this is something that you can see in any computer science book. You can see the pseudocode is available everywhere, so that's not really important. But what I really want to point out is the fact that these JavaScript implementations are not that long, are not that difficult to implement, and it's not black magic. It's at the end of the day, they're simple to implement. So this is the insertion sort implementation of JavaScript. And as I just told you, I mean, I really don't want you to get into I won't get into details. But what I really want to point out is that it's just a 10-line function. It has a for loop, it has a nested for loop, and it's like there is no black magic going on. It's very simple. Anybody can implement that, and you can actually find it in any book, as I told you. This is 10 lines of code. So what about merge sort? The other algorithm that I just showed you, it's a little bit longer, but it's also pretty normal algorithm. You are using a matplotlib, there is some array slice, there is a little bit of recursion. In the second function, there is a while loops, and I mean, it's something that anybody can implement, right? This is 23 lines of code. And the last one is quicksort. So quicksort seems a little bit longer, but as I'm telling you, it's nothing weird going on. There is also a little bit of recursion. There is some while loops over there, and it's a normal implementation, no black magic. It's not that complicated. This is 31 lines of code. Now, the cool thing about all of this is that you can actually extend the array prototype with these self-implemented JavaScript functions, and you can just use it as if they were the native one. Now, am I going crazy? Like, why am I even suggesting the fact of perhaps doing your self-implemented JavaScript functions when there is already a very good one, a native one, probably written in C++ or in C? Like, why would you even care doing your own? So that's a very, very good question. And there are two reasons you might consider creating your own implementation. And the first one is stability. So I promised I was going to explain the concept of stability, and here it goes. So stability. A stable sort is one in which equivalent elements retain their relative positions after sorting. Now, if this doesn't make any sense, I really like this picture because I think it really, really clears up this concept. So in this image, we have a 7 of spades, we have a 5 of hearts, we have a 2 of hearts, and we have a 5 of spades. So basically, the 5 of hearts and the 5 of spades have the same value. Now, if we actually do, we call our sorting algorithm on it, if it's a stable sort, the 5 of hearts, which was before the 5 of spades, is going to preserve its original position, as in before the 5 of spades. And if it's not a stable algorithm, it will just mix, and it doesn't really matter their original positions. Why is this important? So the native sort method in JavaScript, and this is quoting the MDN docs, says that the sort is not necessarily stable. So why would you even care about the stability in your sorting? So imagine you have a Node.js application with a database, and you have an array with a bunch of people, right? We have this Simon Blackburn guy, Lewis Carroll, Gertrude Chataway, and basically they're all just sorted alphabetically by last name. So imagine, besides sorting these people by last name, you also want to sort them by age. So maybe you will do this kind of function to compare them by age. And what will happen? So in V8, in Node.js, actually V8 is using quicksort algorithm, and the quicksort algorithm is not stable. What does this mean? This means that once you try sorting your array by age, since it's not stable, these people that have the same age, as in the same value, 26, their sorting is not preserving the original order. As in, we have this Gabriel Rossetti guy, we have Alice Little, and if you're noticing, it's no longer sorted in alphabetical way. So it's the same thing for these people with 32 years old. It's John Tenniel is coming before Simon Blackburn. So in a general sense, you're getting the point that they didn't preserve the original alphabetical order that they had. And if you care about consistency and stability in your application, you might want to consider implementing your own version. But that's not it. The second reason you might want to make your own algorithm, JavaScript function, is because of performance. Because believe it or not, a self-implemented JavaScript sorting function can actually be faster than the native one. And if you don't believe me at all, let's do some benchmarking. So what I actually did here is I just tested the native Array.sort method against the implementations that I just showed you. The implementations with 10 lines of code, 31 lines of code and stuff, I tested them together. And basically, in this case, it's just a dynamically created array with 10 elements. And as you're noticing, in this case, insertion sort is faster than all of the other algorithms. It's even faster than the native JavaScript method. So what about 100 elements? As you're noticing, insertion sort is also faster than the native versions. With 1,000 elements, insertion sort is still faster. And as I told you before, insertion sort is very good for small arrays. So with 100,000 elements, insertion sort is no longer the fastest, because I told you it's not very good for larger arrays. And as the input increases, insertion sort becomes less performant. But in this case, quicksort takes the lead, and quicksort becomes the most performant algorithm, and it's faster than the native JavaScript function. So what about 1 million elements, like a 1 million element array? So first of all, my computer crashed, because it was too much to handle for the insertion sort implementation. And for the following examples, I'm just going to be showing the native one, the merge sort, and the quicksort test. So with 1 million elements, quicksort is still faster than the native one. And just last example, I don't want to bore you. With 10 million elements, quicksort is still faster. So your homework right now is actually, because what is really important about all of this is that I did this testing in my Mac computer, in a Chrome browser. So of course, these results are going to change depending on the computer that you're using, the JavaScript engine that you're testing. So what I would really encourage you is to actually test away in different machines, different JavaScript engines, and just tell me what are your results. So at this point, you might be wondering, like, how come self-implemented JavaScript functions can be better than the native implementations? It's like, how come JavaScript can beat C++, right? That C++ native implementation. And first of all, one thing. Are you sure that all of the JavaScript engines are written in C++ or whatever? Just if you were actually paying attention to the slides, maybe you noticed that actually the implementations of these algorithms in V8 and in Nitro are written in JavaScript itself. So what am I implying? Is the JavaScript engine written in JavaScript itself? Is this some kind of JavaScript inception? And yeah, it's kind of is. Because actually in the world of computer science, this is called self-hosting. So self-hosting is implementing parts of a language in that very language itself. So then again, you might be asking, like, but isn't C++ supposed to be faster than JavaScript? Like, why would they do that? So C++, yeah, it's definitely faster than JavaScript if they are using C++ structures, but not JavaScript ones. So array methods, for example, we have methods like reduce, map, and of course the sort method. And all of these take a callback as an argument. So the thing is that every time you call these methods, you have to iterate over every element in the array and call this callback, call this function. So the execution has to switch between compile C++ and interpret JavaScript. And the thing is that this context switch is expensive. So if we stay in the same execution context and within the same language, we can actually boost performance. So actually, SpiderMonkey is not self-hosted, V8 is, Nitro as well, and Chakra is not. So to answer the previous question, like how come self-implemented JavaScript functions could be faster than the native one, it just seems that overall there is like an unneeded overhead due to the actual algorithm implementation in every engine. And also, it just seems that the native implementation is just doing more in terms of error handling and features. So maybe implementing your own version could be a little bit simpler. So of course, I'm not saying that you should just go back home and rewrite all of the sort methods that you have ever done to improve the performance of your application. What I'm actually saying is that we have to learn how to choose our battles. We have to learn in which cases would it be pertinent, perhaps, to write our own versions. If you care about performance, if you care about stability in your application, you really, really have to test if it's good enough to do your own version or not. So with that being said, let's talk about something else. Let's talk about the Mad JavaScript party that is just about to begin in a few minutes. So first of all, just a little bit of a disclaimer. The following content is designed to challenge and amuse programmers. It's not made to be suitable for practical use. And of course, with that being said, I'm going to be talking about this non-alpha numerical JavaScript. Perhaps you might have heard of it before. If not, I'm going to be introducing it to you right now. So what's non-alpha numerical JavaScript? Basically, it's JavaScript that works without letters or without numbers. Like, what? Can you actually write JavaScript that way? You can. So before I actually start digging into this subject, I just want to remind you something that you already know. JavaScript is a dynamically typed language. What does this mean? This means that we don't have to declare the type of variables that, the type of data that a variable is going to hold when we're declaring it. Of course, we don't have to tell if it's Boolean, if it's an integer, whatever, etc., etc., etc. This is the job of the interpreter. Now, the problem here is that when we mix types, we can often invoke conversions that can lead to very, very, very crazy results in JavaScript. So what I'm going to be showing you next is how to write valid JavaScript using square brackets, parentheses, curly brackets, the plus operator, and the exclamation point. I swear I'm not crazy. This actually works. You can follow along on your developer tools or in any browser, and it just works. It's crazy. So before I actually start digging into this and I start talking about this topic, let's all remember something very, very basic about JavaScript that we all know. So everything in JavaScript has a Boolean value. Everything can either be falsy or they can be truthy. I have been talking about in the previous slides. So how can we know if something in JavaScript is falsy or it's truthy? So here is the golden rule. Everything in JavaScript is truthy. No, wait, yeah, it's truthy unless it's falsy. Now, if you didn't get what I just told, because actually all of the falsy values by default in JavaScript is false, 0, an empty string, null, undefined, and none. And truthy values in JavaScript are everything else. So it can be a string 0, a string false, an empty array, or an empty object. Now, let's get into the basic of this technique. So what's actually going on in here? So basically, in the first example, we're trying to negate an empty array. So we're forcing JavaScript to treat that empty array as if it was a Boolean. Now, if you remember from the previous slide, an empty array is actually just a truthy value. So we're negating a truthy value, so it gets a false. In the second case, it's way easier because we're just negating a false, so it gets a true. Now, once we have this base of false and true, we have a base to actually write 0 and 1 using the unary plus operator, which actual purpose is to convert things into numbers. Now, guess what? We have 0 and 1. What else can we do? We can create any other number by just adding 1 plus 1 plus 1 plus 1 until infinity. So we can also convert things into strings. And the way this works is, in JavaScript, you can only add up numbers or concatenate strings. So in any other case, if you put other operands in the operation, JavaScript will just transform them into either a primitive type, a number, or a string. So in this operation, the first part is just a primitive type already. It's false, so it's Boolean. And we are either trying to add it or to concatenate it to an empty array. So empty array is not a primitive type. Now, JavaScript will automatically convert it into a string. So basically what we're doing is we're concatenating the false with an empty string, and that gives us a string false. And in the second case, it's just a string true, right? This works the exact same way with numbers. We can convert numbers into strings by just concatenating an empty array. Now, what if we wanted to do longer numbers? Because of course we don't have a lot of time to just add 1 plus 1 plus 1 until infinity. So here's the catch. Actually, we can convert into strings all of the digits in a number. We can concatenate together and then convert the whole thing back together into a number using the plus operator. And 123 looks like this in non-alpha numerical JavaScript, and it does work. Now, if we try accessing an element that doesn't exist in an array, we're going to get undefined. If we try casting an empty object into a number, we will get a none. And if we try casting an object into a string, we're going to get the string object. Now, why is that even important? Once that we have access to all of these words and vocabulary, and by words and vocabulary I mean things like true, false, object, undefined, etc., what we can actually do is transform them into strings, as I just showed you, and we can access every single character in those strings as if they were arrays. So if you are getting the idea now, basically what we're doing is taking into consideration the vocabulary and words that we have available, we can actually create words and functions that actually mean something to JavaScript. So Martin Kleppe, he's the creator of the website JSFuck. Perhaps you might have heard of it before. He called this JavaScript Scrabble, which I think it's a very clever term, because that's exactly what we're doing. With the available set of vocabulary and words that we have, we're just creating functions that actually mean something to JavaScript. So to keep things short, because I don't want to run late on time, we have access to functions such as call, concat, constructor, join, slice, sort, and filter. Now, if you want to see how this actually look in action, let me walk you through this small example. So this is just making an other one in your browser. And this is how it works. The first part is very simple, just an empty array, like nothing shocking over there. And then we have the filter segment. The filter segment is just trying to access the filter function in that empty array, which is a function. Now, that constructor part is just trying to get that constructor of functions. And that constructor of functions can actually take as a parameter a script that will return back a new function with that script as its body. Now, if I guess at this point you already understand what I'm trying to do. The last parentheses are just automatically executing that new function. And the outcome of this code is actually this. Another one in your browser with, and the code that is behind it is the actual code to make it work. So I know it's like very crazy, a lot of things to take in, and this is the last talk, like don't worry. But if you're actually interested in this non-alphanumerical technique, there is a lot of online converters that you can check out just to play around. And what I would really encourage you is to actually see the source code and see how the compiler actually works. So there are things like hieroglyphy demo, there is JSFuck demo, there is 6sharp.js, and JS Screwit. So as you notice, there are a lot of them. And the most well-known is the one by Martin Kleppe, which is called JSFuck. Now, I did a lot of research for this talk, and I came across this really funny-looking repository, which is called jQuery Screwed. And basically, the guy who wrote this repository, he just rewrote the whole jQuery library using non-alphanumerical JavaScript. And this is how the source code looks like. So it's like some people have a lot of time on their hands, unlike me. And at this point, you're probably asking yourself, why would I care about this? Like, I will never write JavaScript this way, and I totally agree with you. I will never write JavaScript this way. But why should you care about it, or why should you know that this can happen? So this is a tweet by Martin Kleppe that I told you before, and he was pointing out to a security blog from a security engineer, actually. And basically, this engineer found that there was a vulnerability on eBay. And basically, what he realized is that it was possible to inject malicious JavaScript into eBay by using non-alphanumerical JavaScript. Because apparently, eBay will prevent JavaScript being run from script tag by filtering script tags or by filtering iframes, but it was totally unaware of JavaScript injected in a different way, in a non-alphanumerical way. So, you know, for security reasons, it's not bad to know that these things can happen. So I also would really, really wish that things would make sense for a change. And And sadly, we are reaching the last part of our journey through Wonderland, but I can't leave without talking about arrow functions in ES6, because I love them. So this piece of code should be pretty familiar to a lot of them. I mean, most of us have encountered this kind of situations before, right? And we all know that it doesn't work because the function inside the syntagma function is no longer in the same context of the foo function. So a lot of us has solved this issue by just adding an extra variable, self equal this or that equal this, and it does work. But it's a little bit weird, and it's like messy, and it's confusing. And what can we do about it? So here's the trick. Arrow functions don't have a this at all. Actually, arrow functions don't have a this. They don't have arguments, they don't have super, and they don't have new target. Any reference to this is going to be lexically resolved up to the outer scope. So we can actually rewrite our previous example by just using an arrow function, because in this way, since there is not this at all, it's just going to resolve up to the full context, and it's going to take the right parameter. So in this case, we solve our issue. Now, what if we are really stubborn and we just want to hard bind a context at this to the arrow function? It's not possible because arrow functions don't have a this at all, and therefore the bind method has nothing to grab on. So in this case, even when we want to hard bind 100 to the arrow function, it's still gonna console out the 42, which is the one in the context of foo. So I guess the takeaway of this small part of arrow functions is that arrow functions are not about syntax sugar. It's not about less typing. It's not about avoiding writing the word function every time you type. They actually have a purpose and a behavior that we have to understand how it works and use it appropriately and use it into our advantage. So, was it all a dream? Like, why would you care learning about all of the nonsense that I just showed you? Like, what practical use can you actually give it? So, it's not a dream. This is true. This is the way JavaScript works. And why should you care about it? And the first reason is that knowledge is power. We have to know why we're writing the code we're writing and how it works. Yeah, and we also have to push the limits of the language. As I was saying before, it's up to us to make JavaScript awesome. And for me, it's already mind-blowing the fact that we can run it on the desktop, on the server, on mobile, on robots, everywhere. It's up to us to keep pushing the language forward and make it more awesome than it already is. We have to continue breaking rules and just playing around. And for me, it's a thing about, for me, playing is learning. And what I mean by this is that it's the quirkiness of JavaScript that just wants me to continue working with it and like learning about it. And at the end of the day, it's this quirkiness that makes me so curious about it and ultimately makes me a better developer every day. And we also have to know that it's all about the power of the language. And this is a quote that I really, really like that says, JavaScript is a language that has survived not despite its flaws, but because of them. And last but not least, I want to show you this quote by Angus Kroll from his book, If Hemingway Wrote JavaScript, which is a really, really good book, and I really advise you to read it. And it says, the best JavaScript developers are those who obsess about language, who explore and play with it every day, and in doing so, develop their own idioms and their own voice. So I really, really highly encourage you to play around with JavaScript, to keep being curious about it, keep coming to this kind of conference, learn, share your experiences with other developers. There is no such things like dumb questions, and just keep making JavaScript awesome. And that's all for me. Thank you very much. I hope you enjoy it. And that's me, Claudia.
Вопросы?
Hi, Claudia. Thank you for the talk. You're really crazy. So I want to make a friend with you. The question is, I just want to understand your thoughts and feelings when you were researching this. So what was the goal, yes, and just why you made it?
Just like I told in the very beginning, I think most of us have encountered, like every time you do something in JavaScript, maybe you have encountered this situation in which something funky happened, like why nan is not a type of number. And of course, we're all curious people, I guess, and we just want to know how JavaScript actually works. And one of the main reasons that drove me to do this talk is like, a lot of people don't like talking about this quirkiness because it's like, it's very weird. But I guess it's just curiosity. We have to learn how to use JavaScript in a more deeply sense. And what I really hate is the fact that a lot of people hate JavaScript because it's weird and it's not as logical or as, I don't know, square as other languages. But this is what makes JavaScript awesome. So, yeah.
Спасибо за доклад. У меня два вопроса. Первый. Есть ли все-таки какие-то конструкции, которые невозможно воспроизвести при помощи JS-фака? И второй вопрос. Как можно защититься от JS-инъекций в том же самом языке, если ты все-таки разрешаешь часть языка? Скрипт-теги я имею в виду.
Hello. Probably I have to translate. Yeah, I'm here. Yep. Hi. Yeah. So I missed the first part of the question. Could you please repeat it?
Есть ли конструкция, которую невозможно воспроизвести на JS-факе?
Sorry, I just can't. Is there any construction that is impossible to reconstruct on this on this JS fuck? Yes. Oh, is it real? Oh shit. Okay. Is there any construction that is impossible to reconstruct on JS fuck?
I really don't. JS fuck as a ideology or whatever you want to call it, I think it's very restrictive. Because as I show you, the way you will make it work is by taking characters of words that we can actually make with those symbols, like undefined, blah, blah, blah. So there are a lot of functions that you cannot create with JS-fuck. So it's, in a way, it's limited. So yeah, it's not that you can write anything using JS-fuck. It does have its limitations.
And the second part? How do you protect yourself from code injections, if it's allowed somehow? How do you protect yourself?
With JS-fuck?
Yes. Yes.
I really don't know. I guess maybe by using some kind of regex and like trying to identify these weird-looking JavaScript in your code. Like, to be honest, I never thought about it. That's a very, very good thing to think.
Okay, thanks.
Еще вопросы на английском, может быть?
If not, don't worry, we can talk in the party.
Greetings, Miss Claudia. I actually came here from Kazakhstan, and it's a country where websites like Dailymotion.com, Tumblr.com, Medusa.io, which you probably don't know, but it's familiar to most of these people, I think. Yes? And all of these sites are blacklisted.
Are what, sorry?
Blacklisted. We can't enter them in Kazakhstan. And I don't know how I will explain back in Kazakhstan that I have visited your talk here. But anyway, tonight we have talked about how using JavaScript we can somehow push the limits of our restrictions that are placed by some of the governing structures, some of the makers, some of the authors. And tonight it was used, tonight in your example, it was used as a hacking device. But how do you think, is there how many of the possible positive возможности, забыл слово возможности, possibilities of pushing the limits are implemented in the JavaScript language or maybe in another languages?
I'm not sure if it's up to me to answer that question, but I feel like right now, as I was telling before, there's a lot of possibilities with JavaScript. It's just a very free language, we can say. It's dynamically typed. So, I mean, I don't work on the specs of JavaScript, but I feel like right now in the current state, I mean, JavaScript is evolving quite fast. And the good thing is that I feel like we're living in a period of web development that a lot of things can actually become a reality. So right now we have ES 6, and there is a lot of proposals for ES 7, and we can also propose a new functionality that we want, and then there's a lot of people that are in charge of actually looking at them and validating them and checking if they're like possible or not. So the possibilities of JavaScript, I think it's up to us. It's keep proposing things, and I think the future of JavaScript looks very bright, and in a very near future we can actually do a lot of things, but just keeping with the evolution of the language itself.
All right. First of all, thank you for the great speech. And the question with this JSFAQ language, it is actually not a game or something to play with. We actually use this part of JSFAQ language in our company, and this is a serious business. So the reason is we use it to obfuscate the JavaScript code. And I
need to talk to you in the after party.
Yeah. So the performance overhead is rather serious, not to mention the increased size, but if we use it like in about 10% of our code, it is still unreadable, but well, it works as intended. Just to say that your speech is actually can be used in real life businesses.
Yeah, it's just part of JavaScript itself. And I knew that maybe explaining into detail this kind of language or JSFAQ thing could encourage people or motivate or give ideas to some people, but yeah, I mean, what can you do?
Yeah, thank you. So it's actually used in the production code, and furthermore, we can not write this all square brackets and plus signs by hand, but we can use automatic transpilers like Babel or something to compile our normal JavaScript code into this fuck-looking code. Whatever.
Yeah, that was just the explanation. As I show, there is a lot of compilers already out there that you can use, and it's automatically.
All right, thank you.
You're welcome.